Here's a tutorial video on measuring volume, and you can pause the screen and read through these big ideas, and pause the screen and check out these learning objectives. You'll have an assessment next class, and this video will prepare you for it. Volume is the amount of space that something takes up. For solid objects, we use centimeters cubed for our units of measurement. Solid objects can be described as being regular or nicely shaped, or irregular, like lumps of clay or maybe an expo marker or an iPod, things like that, things that you cannot use math formulas to figure out the volume. So a regular object you use a math formula for, and an irregular object you have to dunk it in water and see how much water it pushes out of the way. Another cool coincidence here that you should know about, it's not really a coincidence, is that 1 milliliter of water has a mass of exactly 1 gram, and that is not a coincidence. That's something that French scientists made true for us. And another cool thing they did for us is they made 1 milliliter of liquid space equal to 1 centimeter cubed of space. So we say that a milliliter equals a cubic centimeter. Keep that in mind. Here's a block. To measure the volume of a regular object, like a block, you measure this length and you multiply it by that length, and you multiply it by that length. You might think of that as length times width times height, but I get confused by these words, especially when the block turns. So I would not recommend doing this. What I would do is I would pick a corner of the block and measure the length of the 3 lines that come out of it and multiply them together. A more advanced way to think of this is you could think of it as a graph. Here's the x-axis of the graph, here's the y-axis, and then this weird third thing would be the z-axis. So measure the x dimension, the y dimension, and the z dimension. Measure them accurately and multiply them all together, and you'll get cubic centimeters, because the centimeters multiply together as well. So you get cubed centimeters. So I want to do a brief side tutorial on the importance of being accurate. So imagine this student takes a lump of something, puts it on a balance, and it has a mass of 154.0 grams. And then the student takes a ruler and is not very good at measuring, and measures all the sides of this thing to be 2 centimeters, multiplies them together, gets a volume of 8, and then divides mass by volume to get a density of 19.3. Googles it and finds out that the only thing with a density of 19.3 is gold, and starts running around screaming, claiming that he is rich. Student 2 is much better at measurement, takes the same sample, puts it on the balance, and then measures with a little more accuracy. And although this student is only a couple millimeters different than the student before her, being precise in this way affects the calculation of the volume. So you see that by being just more precise by a couple of millimeters is going to have a magnifying effect on the accuracy. So if you screw up your measurements here and here and here, then those errors are going to become magnified and multiplied, or propagated. That's the word we use. And so this is going to be really wrong, because those are all a little bit wrong. And then you're going to take this really wrong thing and divide it into that number and get a really, really wrong thing. So student number 2 has measured accurately, calculated the appropriate volume, did the division, and found out that this has a density of 11.2, which makes it not gold, but lead. And unfortunately, the student is not rich. So measurement is extremely important, especially when measuring liquid volume. So let's keep going here. There's a correct way to measure volume, and there is an incorrect way of measuring volume. Just like batting stances can be good or bad. We have good science and we have bad science. Stay away from these things for measuring liquid volume. They're not accurate enough. You can measure approximate volumes with these things. But if you want to measure exact volume, you're going to use a graduated cylinder or a ruler. So here's a cool thing that happens when you pour water into a graduated cylinder. Water will cohere to other water molecules, but water will adhere to glass, and glass makes up the sides of the container. So let's just look at the left images here. So water molecules adhere to the glass sides with a very strong force, and the result of that is we get this curvy thing that dips downward, and the curvy thing is called a meniscus. So when water is placed into a test tube or a graduated cylinder, it forms a meniscus that dips downward. And we could say that the concave part is facing up. So here it is. And this little dotted line shows us the bottom of the meniscus. If you take a different material like liquid mercury particles cohere to each other with much more force than they adhere to the sides. So they end up piling up, and their meniscus curves upward. So the concave part is now facing down. So the mercury is actually measured from the top of the meniscus. And you can see mercury inside of blood pressure devices at a doctor's office or in old school thermometers. It's a really cool metallic silvery liquid. So when you put water in a graduated cylinder, it's going to form this little dippy thing called a meniscus. So this entire thing is the meniscus. And this right here is the bottom of the meniscus. And the bottom is best seen at the exact center of the tube. So you see a white sort of shimmering light here, and that is the bottom of the meniscus. So that's where we measure from. And we have to make sure that our eyeball is exactly at eye level for the bottom of that meniscus. If our head or our eyeball is too low, we're going to read the meniscus as being a higher marking. If we're too high above the cylinder looking down at the meniscus, we're going to read it as a much lower volume, and we're going to be wrong. So we have to make sure we're at eye level. And here are some students, one of them with an amazing ring, measuring liquid volume at eye level with a pipette, and the water is colored here to help them measure. And here are two more students. So remember also that scientific units are based on tenths, not halves and quarters. So you have to figure out what this measurement actually is. And we have a 50 here and a 60 there. So this is equal to 10 milliliters, which means this is equal to 5 milliliters. So if this is 50, then that's 51 and 52. So we know that this is 52 point something. So in between this space, we have to divide it evenly into tenths. So it's probably 52.8. And we're not totally sure about that 0.8, but we are sure that it's 52 point something. So all measurement includes doubt. It's 52 point something, and we have to estimate to tenths what that remaining digit is. So for next class, again, we're going to be measuring liquid volume, and you're going to end up having an assessment. And I have a second tutorial video here to give you a little more practice with graduated cylinders and volume measurement.